Data structure, once created, will need to be queried, updated, and all unnecessary data will need to be removed from it after proper analysis. Hello viewers, in this video I'll be explaining on the various methods to select the data, insert new columns, and delete unnecessary records from the data frame. For explaining you on the various methods, I'm going to use this data frame DF, which is going to contain two columns containing a series of values 10, 20, 30, 40 and 50 in column 1 and 60, 70, 80, 90 and 100 in column 2. And the index labels are going to be A, B, C, D and E. There are multiple ways to select data from a data frame. I can select the entire data frame or select only one or more columns. When it comes to rows, I can select all the rows or a portion of it, or only the top few or the bottom few rows. I also have an option to convert it to a NumPy format or even to transpose it. Let me explain all of these one by one. For selecting the entire data frame, all that I have to do is to print the data frame, which is going to retrieve me the entire set of records and columns in that particular data frame. For selecting data pertaining to only one column, I can give data frame of the column name. To select data from multiple columns, I can give data frame dot loc of the row values and the column values. Here in my case, I want to select all the rows, so I'm just going to give the slicing operator, which is colon, followed by the list of columns to be displayed. And this is going to be the output of this particular print statement, where I've selected all the rows pertaining to column 1 and column 2. Next is on selecting the rows or the values based on the index values. And for that, I'll have to use ILOC, which is an indexing based integer location. So if I give data frame dot ILOC of 1:2, 0:1, the first parameter will denote the row index and the second parameter will denote the column index. So 1:2 meaning from the row index 1, I'm going to select the values. So the row index 1 is going to be the index with the label B, that is going to retrieve me from B. And since I've given :2, so as we all know, the slicing operator end value is going to be this value -1. So the value that I'm going to retrieve here is nothing but 1:1. So it is going to retrieve only one record here, which is going to be the row with the index label of B. So next I'm going to give the index value of the columns. So I've given 0:1, meaning I'm going to select only the first column value. And this is going to be the output of my select statement. Next we have other functions, which are the head and the tail. And as its name indicates, head is going to retrieve me the rows from the top row and tail is going to retrieve me the records from the bottom row. When I give data frame dot head, it is going to retrieve me all the records from the top. If I give head of 1, it is going to retrieve me the top one row of my data frame, which is this record with the index label of A. And if I give head of 3, it's going to retrieve the top 3 records from this data frame. And tail is going to work on the data selection from the bottom of the data frame. So if I give only tail, it is going to retrieve me all the records of the data frame. And on giving tail of 1, it is going to retrieve me the last record of this data frame. If I give tail of 3, it's going to retrieve me the last 3 records of the data frame. And as I had mentioned, we also have an option to convert this data frame to a NumPy object. So for that, I'll need to call this method, which is toNumPy, which is going to convert this data frame into a NumPy format. Describe is yet another useful function that is going to help us with the summary of the data frame. The summary is going to be based on the columns. So for each and every column, this is the summary of data that we'll get if I call the describe method. Transpose is another useful function which is going to transpose the rows to columns and the columns to rows. the data frame that I had created had 3 columns, which are column 1, column 2 and column 3, and these were the index labels. And on calling this transpose function, the columns and the rows got transposed, but there is not going to be any impact on the data in the data frame. Next, I'll be walking you through the methods to insert values into the data frame. I can either insert the column values by calling the series method, or I can insert a scalar value. The other option is to create a derived column where I can insert the values based on the arithmetic or the logical operators. Slicing operator is yet another method where I can slice a portion of the existing data frame and create new data in the same data frame. So this is the data frame that I have, which is DF, and to this data frame I'm going to create a new column, which is column 3, using the series method. So when I print the data frame, this is the output that I'm going to get. So this is going to be the same method by which I created the column 1 and the column 2. The other method is to go by the derived column. So these are my column 1 values, and to this I'm going to multiply each and every value by 10, and that derived value will be placed in column 4. I can also use a comparison operator where I can check if column 1 greater than 30, then I can create a new column called flag where I can insert the values as true or false based on this particular condition. Scalar value is another method where I can just give one value to this particular column, and pandas is going to insert the same value in all the rows of that particular column. The next method is by using the slicing operator colon, where I'm going to create a new column, which is column 6, from the existing data frame. So I'm going to consider this column 2 as my input value. So which is nothing but 60, 70, 80, 90 and 100. And from this column 2, I'm going to take only the rows from 1 to 2. So the values that I'm going to consider is 70 and 80. And these are the values that are going to be inserted in my new column, which is column 6. In column 6, I'm going to have only 70 and 80, and I'm not going to have any value in the remaining rows. Next, we are going to look at the delete operation, where I'll be using the pop and the drop methods to delete the values from the existing data frame. So I'm going to consider the same data frame where I have values till column 6. To delete only one column from the existing data frame, I can call the pop method, where I can specify the column name that need to be dropped from the data frame. So if I give pop of flag, the flag column gets dropped from my data frame. And this is how the output is going to look like without the flag column. Say for example, I want to drop 2 or more columns. In that case, I can call the drop function. So to call the drop method, I'll have to give data frame dot drop of columns equal to, where I'll be specifying all the columns that need to be dropped from the data frame, and there is another parameter which is in place, which I've given it to be true. So once after the columns are dropped, my select is going to retrieve me the original data frame. So to view the updated data frame, all that I have to do is to give in place equal to true. So all this time we were working on dropping the columns. Now let's get into the rows. So if I want to delete one row, what I can do is I'll simply call data frame dot drop, where I'll specify the index number or the index label. So in my case, I have got the index labels from A to E, and I want to drop the row with the index label B. So I'll give data frame dot drop of index equal to B, and I also need to specify in place equal to true. When I execute this, I can observe that my row B got dropped from my data frame. To drop 2 or more rows, I can give the row labels in the index while calling the drop method. Hey guys, hope you have got a clear picture on how to work with the pandas data frame by performing various operations, by selecting the data from the existing data frame, or inserting new columns or rows or deleting the data from the data frame.